Okay, I believe we are live now. So, welcome to the fourth of the help sessions. The exam is coming closer, so hopefully you get something out of this. Hopefully more people join and have more questions, because last time we were lacking in questions. If you are joining, you can type questions in the YouTube chat, or you can join the Hangout, which is in the link, in the YouTube link. Else, you can join the Hangout and speak if you want. That's also an option. We already have a question, so I'm just going to put it into what's it called? To our window, and then we'll have a look at it. So, we have this here. I'm just going to make this a little bit easier to read. Let's go with that. Let's go. I can't do that. Okay. So if we get something like this on an exam, where it says this is the input and what is the output at the end, we first need to look at our defines. So we've got two defines here. We've got num words is 4 and verbose, which doesn't have any value. So the first thing I notice here, we have define verbose, and we have if def verbose and end if. So we know verbose is defined, so we can completely ignore this, and we know we have to include that printf. However, if it was the other case, and this wasn't defined, so this wasn't here, let's say this wasn't here, then I would go in my exam and I'd just cross all of this out because it's not included, it's not defined. Okay, so when you've got defines, check if it is actually defined, then you do include what's in there. If it isn't defined, then you can just cross the whole thing off and ignore it. Okay. So we can ignore that line, and we know we've got a printf there. Now, we then have num words, which replaces with a 4. So we can look through our code and see, is there any num words? So we've got one here. So this will be replaced by a 4. That is a 4. Okay. So just give me a second. So what have we got next? Give me a color. Let's get red. All right. So now we can just go through the function. So the first thing we have here is a string. It's of length 4 because we have z, 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 and then the null terminating character. So we can just represent that. I'm just going to do it lazily and quickly because I'm in an exam, and just write z, 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 null. We then get to this loop. Now, there's a mistake here. The entire should be up here. That's okay though. Actually, I can edit this text, but I won't do that. So we've got I, which equals 0. If you feel like it, I just write it like that. Then we have car input 4. So now we have another set of letters. So we have 1, 2, 3, 4. And then we scanf 3 characters from the input. So we get pip. And then we have the null terminating character. Now, then we need to do a string compare. So we are making a comparison between the input and S. So this is S, and this is input. Okay, so just one other thing. Sorry. So what string compare does, it will return 0 if they're equal. It will return it will return less than 0 if the first string is less than this string. Now, when I say less than, it's talking about lexicographical order. So what we're saying is input is less than S. Now, this is ZZZ, which is later in the dictionary order. So we've got ZZZ and we've got pip. We can see that this first letter definitely comes before Z. So this is true. So here we would print out our input. So we get pip. And now what we do is we copy the input into S. So now we have here PIP. Now, a good question is what happens with this percent S. Now I just want to check this as well. We have, sorry, give me a second. Here we have pip, sip, cat, and dog. So the next thing we'll look at is the next string. Now, the format specifies, where's a good, sorry, give me 2 seconds. Okay, sorry about that. Okay, sorry about that. All right, so here we now go back up. I is now equal to 1, and then we create this input again. So it's empty, and then we scan the next 3 characters. So for our case, this is going to be sip because it will ignore this space and find the start of the string. So we now have sip in here. And then we compare, is sip less than pip? So we have sip here, and we have pip here. Now, we know from the dictionary that S comes after P, so this is not true. So nothing would be printed. We then go up again. Now, I equals 2. We then grab the next string, which would be, well, we need a new input, sorry. So we're here, we create another new input, it's empty. Then we get the next thing, which would be fat, F-A-T, and then null terminating. Then we do a comparison. And we've still got this pip here because we didn't do the string copy because that was inside the if. So we're doing fat is less than pip. Now we know F becomes before P in the alphabet, so this is true. So that means that we go in here, we would print out fat, and then we copy that into here. Then we go back up again, and now I is equal to 3. We then create our input again. It's empty. Then we scan the buffer again, and we get cat. So now we've got cat in here. Okay, we're only grabbing the first 3 letters because we're using %3s. And then we compare. We've got fat and cat. So we have, which one's first? Cat, sorry, and fat. Cat is less than fat as C becomes before F in the alphabet. So we've got pip, fat, cat. And then we go back up and we've got 4. Now, 4 is not less than 4. So we go down here and we print S. Oh, sorry. I forgot the string copy. So we copy the string from input into here, and we've got cat. Okay, we get down here and we print again. So now we print cat again. I can go back over that again if that was a little confusing. How do you solve this? Okay, so there's another question here, which I don't really get the question. Is that all the question? I think you need to show all the question because that by itself is not enough information. I don't know what the question is. If you have any other questions, add them to the chat or join the Hangout. So the question that's in the Hangout, you need to provide more information because I don't know what the question's asking. So if you have questions or you want to cover a certain topic or you'd like to go over any of the practice exams or previous exams or particular questions, let me know. I'm going to open up LMS while we wait and see if I can get some previous exams. Okay, so the question was using header files. So if we're using a header file, so if we have our C file and in here we have hash include my dot h, and then over here we have so this is, I don't know, let's call it example.c. Here I have my.h, and then I have my.c, and in here I have a function prototype. So I have int func int y, and then inside here I have my actual function. Blah, blah, blah. Then in here, when I go and use it, so now if I'm in my function and I go func2, this will work because my h has included a function prototype, but it is here. Now, if I was to go ahead and do something like this and write int func int y here, or even if I didn't write int y, I could write something else. So let's actually do that case as well. So if I was to write int func here, the compiler would say it would go here, it would include this. So we've got func, and then we'll get here and go, there's two funcs. Which one do you want? So we shouldn't include a function prototype here because we've already grabbed it from my.h. Now, this is the same thing as doing this. So if I go hash include standard IO.h, and then I try and make a function prototype below it. Let's say int scanf blah blah blah. Then it's not going to work because scanf's already been defined and its prototype is already in standard IO.h. So this is why you shouldn't have to include func in your main, because it's already been defined when you've included it. Does that make sense? Cool. All right. Now I'm going to look at the exams. Gmail. Okay, so we're going to have a look at some of these old exam questions. Are kind of horrible, but we'll use them anyway. Okay, so this one's a fairly ugly question, but it's not too bad. So this is from 2012. So it's a little tricky because they've tried to be tricky, but it shouldn't be too bad. So we go about this a couple of ways. We could actually draw the flow diagram for this, which I might do just as a task of practice with flow diagrams. So we have int I equals 0. Then we have a for loop, so we know I equals 3. Then we do I is greater than -2. We do some code. And then we come back and we go I minus minus. So then Might make that a little smaller. No, that's not what I wanted. Okay, so then we've got our code in here. So let's have a look at that now. So in here, we only have two statements. So we've got we have an if statement, sorry. If I equals 0. So this is if it's true, this is if it's false. If this is true, we go here. Now this one's quite an interesting one because we have this break. Actually, so if it's false, okay? If it's false, we keep going and we go to the printf. We'll come back to that other one, the break, in a second. And then we have %d, and then we have I. And then after it's done that print, it goes back up. So it goes here. Now, down here, if it's a false case, so this fails, then it'll go down the bottom and it'll do another printf here. So D, I. Okay, now we also have this break. So this means break out of the loop. So at that point, it will break. So it's going to jump down here as well. So if this is true, it will actually go here. Now, break statements are kind of odd because they break the flow of your program. So you can see that this arrow escapes from this here, which is slightly odd, but it works. This is why you need to be careful using break statements, because you can often get tangled. Because see how we have two entries to this printf at the bottom, and then we just have our return down here. Okay, so that's how I draw the diagram, and then make that a bit smaller. Okay, so now we've got our diagram, so we can easily solve this either by going through the diagram, or we only have one variable, so this makes it kind of easy. So we start off with I equals 0. So I'll just say that's I, and we have 0. So we've done that step. We then set I to 3. So now I is equal to 3. We've done that step. It doesn't loop back, so we can ignore them too now. They never happen again. We then get here. Is I greater than -2? Yep, so we follow the yes. Is I equal to 0? No, so it's the false case. So now it'll print out 3. We then go up, follow the line, and we have I minus minus, so I minus 1. So now we have 2. Is 2 greater than -2? Yes. So we follow the yes. Is I equal to 0? No. So false. And we print out 2. Then we go back up. We subtract 1. So now we have a 1. We go back up here. Is 1 greater than -2? Yes. So we go down. We have the yes. Is I equal to 0? No, it's not. So we go false. We then print out our 1. Okay, it's just printing out I. Then we go back up. We have I minus minus. So now I is going to be 0. 1 minus 1 is 0. Is 0 greater than -2? Yes. So we follow this yes. is I equal to 0? Yes, it is. So now we follow this. So now we go down an alternative path and we break out of the for loop. So then we get here. And what do we print? 0. So we get 3, 2, 1, 0. Does that explain what you wanted from that question? Now, let me just check if there's any other. Yep, okay. So now I'll just grab the other question you asked about. That's not a horrible one. Oh, okay. This is a fun question, and I think it's a really good question. All right. So what I might do is print screen, put that in there, grab this question. So the second question that's been asked in the Hangout is this question. So this is one from the 2011 exam. So let me just close that down and close that down. All right, so here we go. So this one, we can see that we have bitwise operators already. Just going to do that. So I can see that there's bitwise operators, there's multiple of them. So the first thing I would do is convert these two variables into bits, just to make it easier on ourselves. Now this is an int, meaning that it would be 32 bits, but I'm going to ignore the first, what's it called, 24 of them. And I'm just going to look at the bottom 8. So we have 5. And then we have 2. Okay. So we have x is going to be, actually let's ignore even more. Let's ignore the bottom 28. Because yeah, I don't think we go much further. So I'm just going to ignore the top 28. So we have x, which is 0, 1, 0, 1, and we have y, which is 0, 0, 1, 0. So we've done that step, and then we've got, which is just some value at the moment. Now, it's this line. So we have z equals x shifted 2 places. So we have x here, and it's going to be shifted 2 places. So if we shift it 1 place, we get 1, 0, because we've moved it across 1 place. And then if I shift it again, we get 0, 0, 0, 1. So z becomes 0, 0, 0, 1. So don't forget, there is still 28 zeros before this, but because we know they're all zeros. Okay? There's 28 zeros here. Okay, and that goes for all of them, but I'm going to ignore that. So we've done that step. Then we've got this next step. So we've got z is y bitwise OR with z. So y is 0, 0, 1, 0. As I showed you last time, you can just do it like this. And then we've got z, which is 0, 0, 0, 1. Now, a bitwise OR is true if both are 1s, then you get a 1. A 1 and a 0 gives you a 1. A 0 and a 1 gives you a 1. And a 0 and a 0 gives you a 0. So this is the OR. So we have 0 and 0, 0 and 0, 1 and 1, and 1 and 1. So now z becomes 0, 0, 1, 1. Okay, I'm just reading down. Okay, so you can stack them this way if it makes it easier to make a comparison between each two. So now Z becomes 0, 0, 1, 1. Okay. So we've done that step. Now we've got X becomes Y, bitwise and Z. So on the left-hand side, we have 0, 0, 1, 0. Oh, right-hand side. Well, left-hand side of the and, sorry. And then we have Z. So we've got 0, 0, 1, 1. So if I stack them next to each other, zero. So for and, we have 1 and 1 is 1, and everything else is 0. So you could quickly draw these in the exam right when you start if you want. You've also got XOR, which is the little caret, which is 1 and 1 is 0, and 1, 0 is 1, 0, 1 is 1, and 0, 0 is 0. So they'd be good things to draw at the start of the exam if you're stuck. So let's add these together. So we get 0, 0, 1, and a 0. So the result of this is going to be 0, 0, 1, 0. So X now becomes 0, 0, 1, 0. So we've done that step. Now we've got one more step. Is that an L or is that a 1? Yeah, it's a 1. It looks like an L. That is a bit confusing. So now we have Y equals 1 shifted 2 places. So here we have 0, 0, 0, 0, 1, and it is shifted 2 places. So shifted 1 place would be 0, 0, 1, 0, and shifted 2 places is going to be 0, 1, 0, 0. And then we set that to Y. So now we've got 0, 1, 0, 0. Now we've done all of this. Now we just need to print it out. So we need to work out what each of these are in decimal. So we can do this a couple of different ways. We can treat this as 1s, 2s, 4s, and 8s, and we can just add them up. So 1 times 0, 2 times 1, plus 4 times 0 times 8. So we know it's 2. Okay. This one here, we've got 1, 2, 4, 8. This is 4. And then we've got 1, 2, 4, 8. And 1 plus 2 is 3. Okay. Does that answer L? Then we'll get on to the question in the YouTubes. Cool. All right. All right. I'll just post the Hangout link again if you want to join the Hangout. Join. It's a lot easier if you can walk through what you know and don't know. So I'm going to have a look at H for 2011. H. Is there a H? Yes. Maybe it's H. Did I already go for this one? I'm not sure. Okay. This is a kind of horrible one as well. Cool. Okay. Is this the question we wanted? Now, this question here is kind of neat. So we're using array notation, so that makes it easier. I note that we've got this 5 here, and we have malloc. So I see that there's 2 variables in this whole thing. There's no other variables, which makes it easy, so I only need to deal with 2. So I'm going to use box and pointer diagrams for this because I think it makes it easier. When you're in an exam, you don't have to do them all really nice when you're trying to work out a question. You can just do a shorthand version, but you still should show how you got your working, and when pointers are involved, it's going to be a lot easier if you just draw the diagrams. But yeah, you can have a shorthand version. So I would just usually, unless I need it, I wouldn't bother with the type if I was trying to go quick. And I'd usually leave a little bit more room in here so that I could write multiple answers multiple times. So we've got A, which is an int. Then we've got a pointer. So we've got, it's called ptr. It's type int star, and we know it's a pointer. Then what we have over this side. So we have memory allocation. So let's look at this first. We have size of int, okay, times 5. So we can do this multiple ways in terms of how you want to represent it. But because the size of is an int, we can just represent these as ints. You can do funky things with memory allocation if you want. So you could use other types there and do multiple types, but we won't do anything like that on the exam. So it's just going to be one type. So you can keep it kind of simple. So we've got a bunch of memory allocated. We've got 5 ints. Okay. But this memory allocation doesn't give them a name. Okay. So the problem with this is if I lose this array, it means that it's gone forever. Because I won't be able to find it because there's no names associated with it. So we create this. So we've only done this part yet so far. Then the malloc returns a pointer. Okay, so it returns this. Okay. Now this pointer we want to treat as an int star. So we typecast it. And then we set that pointer to be the value of ptr. And now we've got this. So you can see that we have pointer points to the start of this array. And inside here, we don't know what this is. If we were using calloc, they'd all be 0. Okay. But I rarely use calloc, so. All right. Now we know how a for loop works, I hope. Okay. So we set the value of A first, then we do a comparison. If it's true, we do some code, and then we go back up and we do the increment. Or whatever the operation is. It doesn't actually have to be an increment. It's just an update. So this doesn't actually have to increment. It can decrement. It could do whatever it wants. They're just separate operations. None of these have to be like this. So it is possible that you may see something like for, this is just, I'm going on a sidetrack here. Y equals 0. Y, actually, let's go. B is equal to 3, and then have something like W equals 2 divided by 4 or something. That's a very stupid example, but you get what I'm saying. It doesn't have to be in this format of always the same thing. This does have to be a condition though, this middle one. It does have to be a condition. The other two can be anything really. All right, so we have a equals 0. Is a less than 5? Yep. So now we get here, and we have pointer a equals a minus 2. So let's have a look at this pointer a. Now, what this is actually saying, if you want to get technical, it's actually saying star pointer plus a. Okay? These two are equivalent. So what we are doing, if we have a look at this expression, well, this is on the left-hand side, so we should evaluate the left-hand side, right-hand side first. So we've got a minus 2, which is minus 2. 0 minus 2 equals minus 2. So what this is saying is basically we have our pointer. We want to increment by a. So it's an int pointer, so it's going to increment by ints. Okay. Remember, this addition and subtraction for ints are done as the same size as the pointer. Because these are 4 bytes long, plus 1 will add 4 bytes because it's an int pointer. And this is why the type of the pointer is really important. Because if you had the wrong type here, you try and access something in the middle. Okay? But because if you set these up correctly, you don't have to worry about that. And that's the good thing about it. So we've got pointer plus 0, and we're dereferencing it. So we're saying what we want to do is store -2 where pointer points, which is there. Or we could look at it this way and go pointer 0 equals -2. So here we have pointer index 0. So remember, this starts at 0 equals -2. So now we have -2 in there. So you can use either notation. I think it's good to understand this because you can see the relationship between the pointer and the array. This notation is a little deceiving. And if you can avoid it, it's actually kind of good. All right. So just let me know if you're following still. That's making sense where we're up to. Yes, no, maybe. All right. So now what I'm going to do is I go back up. I've done that. So I go back up and now I add 1. So I get a 1 here. We then have a 1. We have a 1 here. So now we have, and we also have a minus 2. So we have 1 minus 2, which is -1. So now we'll see a -1 here. So here, this time, if we have a look at the pointer notation, we have pointer plus 1. So we're looking at it here. Okay? So we're saying this pointer for 1 int. Okay? So now we're looking at here and we want to dereference that. So we want to store, because the, sorry, because the dereference is on the left-hand side, we are storing it where that address points because it has the, what's it called, dereference. So now this would be -1. Now, from this, we can already see a pattern. Let's do it one more time, and then I think we can work out what the last two are going to be, and then we'll go to the bottom section. So we go back up again. We get 2, 2, that's 2, which is 0. And then we have 2, 2, 2, and we have 0 here. Okay, so we'd get a 0 here, because now we're dereferencing this plus 2. Or you could think of it as index 2. Whatever makes it easier. I actually think this is easier, but this may appear easier. Now we can see what's happening. So we know that this would equal 1 and this would equal 2. Okay? At that point, we can see this loop repeats 5 times because it goes from 0, 0 to 4. And we know that it's just going a minus 2. 0 minus 2 is 2, minus 2. 1 minus 2 is negative 1. 2 minus 2 is 0. 3 minus 2 is 1. 4 minus 2 is 4. Okay, so we've done that part. And once you see the pattern, you can probably just quickly skip over the rest of it and just assume that you're right, and then come back to it later and just double check that this pattern was true and your assumption was right if you have time. All right, so at this point, A would be 5. Okay, so we're just here. We've just exited because A is not less than 5 is not less than 5, and then we set A to 1. So that, well, whoops. Nothing loops back, so all this is done. We can ignore that now. I probably wouldn't cross it out if you're actually on the exam there, just because you might want to look at it again. All right. So here we now have while A is less than 4. So now we're printing out pointer A, and we're grabbing the value and printing it to the screen. Now, be very careful here. Okay, so we have pointer 1. So we know that's the same thing as pointer plus 1 dereferenced. Now, some people may get the urge to print that one, but it's this one, okay? It's this plus 1, okay? The indexes start at 0. So pointer 1 is going to print out negative 1. We then add 1 to A, and we get a 2. Is 2 less than 4? Yes. So then we go to the next one, and we print out 0. We then increment, and we've got 3. Is 3 less than 4? Yes. So then we print out this one. Then we add 1, so we get 4. Is 4 less than 4? No. So we only print out negative 1, 0, 1. Happy with that? And then I've got a question for you. Oops. Ah, damn it. Okay. So just further than that, let's say this was inside a main function, int main. What do we need to do? Let's say the return's here. What am I missing? If everyone can type something, it would be a good idea. Like, and if you don't know, just write don't know. I just want to see who's participating. Beautiful. So we have, someone suggested free PTR. So this pointer is pointing to unnamed memory. Okay, so it is really important that you free it. Okay, so this gets freed. All right, so don't forget that if you have pointers, if you have malloc in your code, okay, especially when you have to do your own code, because there will be a question in the exam about writing your own code, and if you have to use malloc on that, do not forget the free, so I can guarantee you lose marks. All right, so now we have another question from, oh yeah, and includes, because there's printf. Good point. So now we have a question from the Hangout. So scoping. So scope in your code. So if I have, let's say, int main, int x equals 4, and I have if x equals 4, then I have int y equals 5, then I have printf %d x y. Then I go down and I go int z equals 6, and then I have some brackets here just for fun. I have int w equals 8. Then I have printf %d and I have x, y, z, w. Okay, so I'm just going to make that a little smaller. It's going off the screen. Okay. So, which line here would cause an error? And how would we fix it? Which printf? I'm not drawing. The first one? Why would that one cause an error? Okay. So either of the printfs will cause an error. I'm not saying which one. Tell me why. And if you don't know, write I don't know. Please. I'll give you a couple of minutes. Actually, I might change the question a little bit. What I'm going to do, just so it makes it easier to get an answer. X Y Z W. Hopefully you can still read that. So one or more of these four will cause an error. So in the chat, if you know the answer, which ones will cause an error, which ones need to be removed, just write the letters down or write I don't know, please. I'm waiting for some replies. So if you're watching, please put in the chat what you think. This one would fail, this one would fail, this one would fail, or this one would fail, or multiple. Okay. So let's have a look at this. So we have X here, which is in scope between here and here. Okay, because of the two braces. Okay, so X is in scope, so it's fine. Y is declared between here and here. So it is only in scope here. So it's fine to print it here, but it's not fine to print it here because it can only be seen between these two braces because it is defined in here. If we have Z, Z is defined within these two braces. Okay? So Z is perfectly fine too. So when looking to see if it's in scope or not, we look between the braces where it's defined. So we can see that this is defined between here. Now, if you've tabbed stuff as well, we could look at the tabs and work out where everything is defined. The W is only defined between here and here, so it is not fine. Okay? Now, a lot of people still get confused about this. This here doesn't have an if statement, doesn't have a while, doesn't have a loop or anything like that. We can use these braces just to define scope. Anywhere in your code, you can put these. There has to be a matching one, but you can put them anywhere in your code. And it means if you define something in there that is only limited to there. and you can't use it after this brace. Now you can do some funny things like this, and this is legal, but stay away from it. All right. So, more questions. Did we go through everyone's? Yeah, we went through H. Cool. Grab. Okay. So, give me a second. If you have any questions, put them in the chat. I just want to check something. So if you've got any questions from previous exams or anything like that, put them in the chat. I'm relying on you to raise the questions, so I'm not just talking about random stuff. Else we will go through something from the previous exam. I'm just looking for a question. I'll give you a couple of minutes to try and find questions. All right, so what I might do is I'm going to leave, not leave, I'm going to open this question. So this is a pretty good question. It's fairly simple. It's similar to your assignment, actually, in some regards. So this is question 2 on the 2011 exam. Okay. So we have here, given the following structure declaration, blah, blah, write a function called print large houses that takes the following as arguments: an array of struct house t and an integer num house that stores the number of houses in the array. The function prints out the address and price of every house which has 4 or more bedrooms. The function prototype is as follows. For example, if H array contains the following, blah, 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 we then call the print large house as follows. So we pass H array, which is in our array. We can see that there. And we pass 3 because there's 3, 0, 1, 2. We are printing out ones that have more than 4 bedrooms. This one has 5, this one has 2, and this one has 4. 4 or more, sorry. So to print out these two, which we get 12 Peel Street, Melbourne, price $2 million, and under $2.9 million with 2 decimal places. Okay, so what I'm going to do, I want you to have a quick attempt at this. It's 10 marks, so it should take you about 10 minutes to do. So I want you to attempt this, and I'll be back. And then we'll go through the answer or my solution. There's multiple ways you can go about a lot of these questions. So if you have a different way of going about it, see how it goes. But try it and then put your answer in the chat if you can. Or if you don't know how to, just say you don't know. And I'll be right back. I'm just going to mute myself. Okay, I'm back. Do we have an attempt at this question? Is anyone able to solve it? Am I talking to myself? If you're still there, can you please let me know? All right. So I'm just going to go quickly through this question. So we got one answer, which looks pretty good. It's missing one thing, but other than that. Okay. All right, so where are we? Okay, let me just check the YouTube to see if anyone answered that. No. Cool. All right, so we had one answer, which looks pretty good. It's just missing one tiny thing, but that's okay. All right. So let's have a look at this. So write a function called print large houses that takes the following arguments: an array of houses, and we have what the struct looks like. So that's awesome. Then we have how many, okay, are in the array. Awesome. And it stores the number of houses in the array. Cool. The function prints out the address and price of each house which has 4 or more bedrooms. The function prototype is as follows. Awesome. So we've got the function prototype. So the first thing that I'd look at here is that I've got an array and I've got to do something for each one of them. So I know that there's going to be some kind of loop. I also note that there is some kind of condition. Okay, so I know there's going to be some kind of condition. Okay, I know how many times this loop iterates. So if it's known, generally a for loop's a good idea, but we can have a look at that in a sec. So how I'd go about this is first, I'd just write exactly what's there and just write the function. So void print large houses struct house t. What is going on? Sorry, I don't know what happened to the screen. House t times, not times, it's a pointer to an array. And then we've got, I need more room. Give me a sec. Let's put that there. That'll fit. All right, so we've got that. And now we have H array and we have int num houses. So what we already know is that we have some kind of array. Okay. And we know in that array, each one of these is of type struct house. Okay, and because it's a struct, it has multiple types inside it as well, which has 3 more types inside it, which will also have a value and a name. Okay, what we have here is a pointer to the start of this array, okay, which is known as H array. Okay, and this is a pointer. So this is going to point right at the start of our array. It is going, because it's a struct house pointer, it's going to increment over each of those structs, even though they have multiple things inside them. So they have multiple levels, because the bigger box is our struct house T, and then it has multiple smaller boxes inside. So it has address, it has number of bedrooms, and it has number of price. If we were to draw this out, we'd have to write 200 boxes, so I'm not going to draw that out in full. Okay, but we can see what it kind of look like. We have this H array, and we know how long it is. It's num houses long. Okay, so this could go on further, or it could be shorter. Okay, so as I said, I know that I have to look at each one of these. So I'm going to have some kind of loop. I'm not going to specify what loop yet, because I don't care. I just know that there's some kind of loop. Then I know in there, the only thing I need to do is print out price and address if the house has more than 4 bedrooms. So we've got some kind of condition. So some kind of condition, which we can assume is an if. We know that we are going to print in there. We're going to print out the address and price. Now, if we look at the output, we can see each one is on one line. So we've got house address equals 12 Peel Street, Melbourne. Price is this. So we might as well just do one printf function in here. So it's void, so I know I don't have to return anything. I'm not using malloc anywhere, so I don't have to free anything. So I would just close that function. That would be how I'd set this up. Then I'd look at my loop. How many times do I need to loop? As I said before, we know how many times we have to loop because we have this num houses. So we can use a for loop. There's no reason why you can't use a while loop or a do while loop. If you really don't use a do while loop, because this could be 0. So if there's no houses, we don't want it to continue. So you could use either a while loop or a for loop here. So let's make a variable called int I. And let's I equals 0. How many times do we want to check each house? For this one, we have to check 3. For ours, we need to check num houses. So while I is less than num houses. Is it houses? Houses, yeah. And then we just increment to look at the next one. So here, I need to check, does the house have more than 4 bedrooms? Now, we know we have the H array. I know I can index it using these braces. So I can look at index 0, 1, 2, 3, and so on. I want to use this I because I want to iterate and look at each one. So I've got if H array I. Then what I want to do is look at the number of bedrooms. So I go up to my definition and I have my second thing here, which is num bedrooms. Now, be careful here. Because this is a pointer, doesn't mean that we use this, because we have used this. Okay, so this has dereferenced it. Okay, because remember, previously, this is the same as saying H array plus I star. So we use a dot here. Okay, because we have this brackets here to reference which one we're looking at. This H array is not a pointer anymore. Okay? If we were looking at H array by itself, then we would need to use this. If you wanted to use pointer arithmetic, you'd have to use this, but we're not using pointer arithmetic. And if you want, we can go through the solution using pointer arithmetic too, if you want. So we have H array dot num bedroom is greater, what have we got? Greater or equal to 4. Then we do a printf. Now, I'm going to have to write really small to get this all in. So what text in these outputs changes depending on the output? So if we have a look at this, house address equals and price are always the same. This and this changes. Okay? So we need format specifiers here and here. Now we could do this in 2 printfs, which I might actually do just to save space. So we have, at the start, we have house address. Equals. And then we want to print out a number. So I go up the top. Oh, wait. Sorry. No, we don't. We want to print out the whole string. Sorry. That was my fault. So we want to print out this whole string. We know it's a car array, so it's a string. So we can print out %s. And then we have a little comma there. Now I'm going to leave it there. And then I'm going to grab my H array I dot what is it? Address. Cool. Then what I'm going to do is print the next line. Well, not the next line, the next part. I haven't used the new line here, so it's still on the same line. So that's all good. Then we have a space, and then we have price equals. Now we have a dollar symbol. And then we have the price, which is a double. So we first need to note that we've got a 0.2 because we have, why did my screen disappear? Oh, it's back again. We have a 0.2 and we have a long float because it's a double. Now, the 0.2 is for the 2 decimal places. And then we have a new line so that we go to the next one. And we have H array I dot price, I think it is. Double check. Yeah, price. And then that should work. Does anyone have any questions or problems about that?
Yes.
So any questions? So, oh, and I made a mistake. It should be $% dot 2. Okay, so just something to note. Don't forget, if you've got a double, it's a long float. is as a print specifier, and don't forget your point true. All right, is there any other questions? Anything else you want me to cover? I'm happy to answer anything if you've got questions or anything really. All right, so I'm just going to leave it to you. If you've got any questions, put them up. If you don't want anything answered, then we can finish it early. Yeah, so it's up to you if you want more examples or anything like that. I'm not just going to cover stuff randomly because I don't know what you want to know. So happy to stay around and answer questions, but I just need questions, or else we'll finish early. Which should be inside. All right, so just got one other question. Let me copy and paste it. Okay. So there's a question about this. Where are we? Sorry, I've lost the Hangout thing. All right. So You should be able to describe, based on the lectures, what the difference between these two are. The major difference and the major keyword here is going to be the word dynamic. Okay, this is dynamically allocated memory. Okay, so we're actually allocating the memory at runtime. Here, we are creating the memory beforehand. So when the program starts, it will be created. This has its advantages because it means we can change the size of our variables at runtime. We can set the size of them, and we can change and free the memory as we please. This we don't have much control of. This is also better memory management if we don't know what this value is compared to this value. If I was doing this, I'd probably show a little example to explain it. But you should be able to pick up the key points about this. And there may be some good definitions in the lectures. Is that all right? Just quickly, the other thing about this one compared to this one, this is a pointer. This has a pointer to the start of the array, but we can't change it. This one we can change where it points to. So this one you can end up with memory leaks if you lose the start of your array. You can't lose the start of this array. Okay, and that's why in the labs we made copies, etc. Anything else? Or I think we're done. People are leaving anyway. All right. Hopefully we can run another session before the exam. I'm happy to stay as late as possible, but if there's no questions and you're fairly confident, then that's fine as well. Yeah, I'll stay for another 5 minutes. If there's more questions, we can answer them. But yeah, I might leave it there. All right. All right. Thank you very much for coming. I'm going to stop it there.